Number 7, Mr. Hickam loves his latte, flat white, or cappuccino in the morning. That's basically coffee, guys. To make any of them, he first makes a double shot of espresso. Sadly, on this morning, he made his espresso, but then his little Weasley dog Ruby had to go outside. In the time, his espresso started getting cold. Here's a chart of the temperature for each minute. If the espresso continues to decrease in temperature at this rate, at what will the temperature be at 10 minutes? So in 10 minutes, here's this. I want to know, hey, at 10 minutes, what should I expect the temperature of my coffee to be when I come back inside after taking the dog out for 10? Okay. So it originally came off the machine at 150. Then it dropped 9. Then it dropped to another 9. Then it dropped. So it's dropping. Well, we know it's dropping, so really I can sort of see that it drops and then it's going to even out to some temperature because eventually it's going to get to room temperature and sort of stay right there and never go below that, right? So I can see this is exponential decay. So I need to go and sort of graph this. So let me go over to Desmos, pull up Desmos. Here's my graph. Okay. To put it in a graph, you just hit the plus and hit the table. I've already done it for us. So we can see on this guy, if we look at it, there's my coffee getting cold. And I want to know when I'm out here, what's this going up by? It looks like it's going by 10. So I want to know when I get in this range of 10 right here, what's it going to be? Okay. So I need to create a line or a curve of best fit. So I'm going to come right here. Let's open this up. You can use the keyboard or you can just use this. So we're going to go Y. I need to tell it my data. So I'm going to say sub 1. I then need to put a little squiggly. To get our squiggly, we're going to end up going to the ABC, or on our keyboard, it's the shift and the button at the top left, up near the top left. Now, the reason I do the 1 is because it's saying, hey, look at my data. Because notice this data is in Y1. And that's why when we use the X, we're going to do X sub 1. Now, I know this is some number A times, I'm going to go back to get my multiplication, times b raised to a power. So let's go b raised to the x. So b, now I want to raise it to the x. On the computer, you can do the caret. Here, we're simply going to go back. This A to the B button, I'm going to hit it, and it raises it up. X, now I got to make sure I put 1. Once I do that, it then draws the line for me. Notice it's hitting my points. So I want to see, hey, what is it when I have 10 here? So what is it going to be? All right, so let me close this out. It says, hey, we have a pretty good idea of what it is. Your R squared value, your correlation coefficient, is almost perfect. This is almost a perfect exponential decay. Okay, so the A value is 149, about 150. So if we come back here, it's about 150, okay, which notice is my starting temperature, times, we come back, what was our B value? The B was 0.939, so about 0.94. So 0.94 times 0.94 to the X. Now, what I could do is simply come in here and do 150 times 0.94. The X, we want to know at 10 minutes to 10. Now, I don't know what that is. I'm going to grab a calculator, do 150 times 0.94 caret raised to the 10th power. Let me hit a times. I hit the wrong button. And it says AC, so your coffee is going to be at 80.8 degrees about. All right, so my coffee is going to drop from 150 down to 80.8, almost half in 10 minutes. That thing's cooling down. So what if I wanted to look at Desmos? Well, there's your answer, 80.8, somewhere in that range, you're fine. I could go to Desmos, and I could come down here if I wanted into a third thing and say, hey, I want to draw a line right at 10. So I could say, hey, draw me a line, okay, at X being 10. X equals 10. And notice it draws a line, and I could click right on that dot, and it says, hey, when X is 10, it's crossing right on my blue line, 80.1 degrees. So about 80.1, you and I had said 80.8. So 80.1 is actually a little more accurate. Now, why did I have 80.8? Because I rounded this a little bit and I rounded that a little bit. So 80.1 is the much better answer. But if you're in 80, I'm happy. Okay, just to the nearest whole number, I guess 80 degrees or 81 degrees. Either one, we know my coffee's cold. I'm not happy.